I want to look at these limits, and I want to use limit laws to do this. And so we can use some algebra to actually solve these instead of having to using tables. And so for example, the limit as x approaches negative 1 of x squared minus 4x over x squared minus 3x minus 4 will be our first question. And I want to point out that in these, if the limit point is in the domain of the function I'm working with, then I'm allowed just to plug it in. Okay, so for this first one, what I'd want to try to do first is factor. So I factor out an x out of the numerator. The denominator factors as x minus 4, x plus 1. And you can think the way I got that is two things that multiply give me negative 4, add to give me negative 3. So from there I can see that the negative 4's cancel out. And so I'm actually dealing with the limit as x approaches negative 1 of x over x plus 1. Now, at this point, if you notice, if you plug in negative 1, you end up with a negative 1 over 0. So I still am not allowed to plug in anything. But I know that from my limit laws that I can break this up accordingly. The limit is x approaches negative 1 of x times the limit is x approaches negative 1 of 1 over x plus 1. And the problem we have to worry about here is the second part. But I remember a theorem that says if I approach a from the left of 1 over x minus a, I go to negative infinity. And if I come to a from the right of 1 over x minus a, I go to positive infinity. Okay, so since 1 over x plus 1 is the same as 1 over x minus a negative 1, and I'm approaching negative 1, I know from the left I'm going to negative infinity, and from the right I'm going to positive infinity. So from both directions, actually it does not exist. So my limit here does not exist. However, we could play on this. If I decided to take this example from the left instead of from both directions, then I could evaluate. The first term here is a polynomial, so I can just plug in negative 1. And the second term, I'm coming from the left, so by my theorem, this expression is going to go to negative infinity. So negative 1 times values that are getting increasingly large in the negative direction ends up with values increasing large in the positive direction. This limit would go towards infinity. And I could also play this game if we decided to go to the right hand side. So if I made this the right hand side instead of the left, then I'd play the same game except I just use this expression. So that's going to be negative 1 times, well, a positive infinity if I'm coming from the right. And so negative numbers times values that are increasingly large get increasingly large values in the negative direction. Okay, so this, again, this is from the left in the yellow, and the purple here would be from the right. Okay, but the way the question originally was stated, it does not exist. Okay, for the next example, we have the limit as x approaches negative 4 of 1 over 4 plus 1 over x divided by 4 plus x. Okay, we don't like this expression because we get a 0 in the denominator for 1, and also we don't like fractions within fractions. So what we need to do first of all is let's use some algebra to bring these things together in the numerator. I'm going to have a denominator of 4x. That was my common denominator. Okay, now for the first term, I had to multiply an x over x to get that. So I end up with an x over 4 plus x. My second term, to get 4 over x, I need to multiply by 4 over 4. So here I end up with 4 over 4x divided by 4 plus x. Now I like getting the common denominator, even though at first it looks more confusing, because now I'm allowed to bring those together as x plus 4 over 4x divided by 4 plus x. So dividing by a fraction is the same as multiplying by the reciprocal. So here I end up with limit as x approaches 4 of x plus 4 over 4x times the reciprocal of 4 plus x, which is 1 over 4 plus x. And now notice that I have these terms cancel out. X plus 4 and 4 plus x are the same thing, aren't they? So here I end up with the limit as x approaches 4 of 1 over 4x, and 4 is in the domain of 1 over 4x, so I'm allowed to plug it in and end up with 1 over 16. Okay, this last example we're going to look at is the limit as h approaches 0 of x plus h quantity cubed minus x all over h. And if you notice, if I plug in h equals 0 here, oh, and actually this is supposed to be x cubed. If I plug in h equals 0 into this, I end up with 0 over 0. Okay, so we need to manipulate this somehow. And the way we're going to do that is by expanding out this x plus h cubed using Pascal's triangle. And if you don't know how to do that, it's worth looking up how to do it. It's very useful. But here's what it's going to look like when you do. You're going to end up with x cubed plus 3 times x squared times h plus 3 times x times h squared plus h cubed, and then we have the minus x cubed at the end, and all of that over h. Now, if you notice, what happens is that some stuff cancels out. The x cubes subtract out for 1, and so I end up with 3x squared h plus 3x h squared plus h cubed all over h. And now I see every term has an h in it, so I'm allowed to cancel out those h's, and I'm left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And now when I plug in 0 for h, I end up with just 3x squared. And there's my answer. Using limit laws makes evaluating limits so much easier because we don't have to use tables, we don't need to use computers. All we need to use is algebra. If you have any questions on these or you have more algebra questions, please let me know. I'd be glad to help. I hope this makes sense. I hope it clarifies some of the mystery behind how limits work. And if you need help, again, just let me know. Thanks for watching.